Today we're going to learn about applications of the chain rule. Let's say we have to solve the problem like this. Find the derivative of a, e to the 2x to the 7th power, and b, f of x is equal to 5x squared, and g of x is equal to 1 over x. Find the derivative of f of g of x. So before we get started, let's first look at the problem. Here we see that we have e, but instead of having e to the x, we have e to the something other than x. So now whenever we have something other than x, we have to use what is called the chain rule. The chain rule is the rule that says that h of x, if h of x is equal to f of g of x, so here as you can see we have the function, and then we have something other than x, which is g of x. So if h of x is equal to f of g of x, then that means that h prime of x is equal to f prime of g of x times g prime of x. So what this is essentially saying is that the derivative of h of x is equal to the outer derivative times the inner derivative, or inner d. D stands for derivative. So, let's move on to problem A. Before we can start it, let's first isolate the two parts. So, the first part, or the outer function in this equation, would be e to the x. The inner function would be 2x to the 7th. And keep in mind that you can have more than one. So instead of or more than two functions. Instead of having e to the x to the 2x to the 7th power, you can have e to the x to the 2x to the 7th power, and then you can have another function. In that case, you would have to do what is called a nested chain rule, when you have more chain rules within one chain rule. So, now that we have these two parts, let's get started. The derivative would be, notice here how when it says f prime of g of x, so that means that instead of finding the derivative of e of x, we have to find the derivative of e of x, which is e of x, but instead of putting x, we have to put the value that was always there, which is 2x to the 7th power. So we have to do e to the 2x to the 7th power times the derivative of the inner function, which is 2x to the 7th, and the derivative of 2x to the 7th, as we know, is 14x to the 6th. So that means that the derivative of e to the 2x to the 7th power is d over dx of e to the 2x to the 7th power is equal to e to the 2x to the 7th power times 14x to the 6th. Now let's move on to problem B. In problem B, we're already given f of x is equal to 5x squared, and g of x is equal to 1 over x. We're also given the composition, so that we know that f of g of x is what the function is. So f of g of x would be 5. Now instead of putting an x here, since it's a composition, we have to put in g of x in for x, because we know it's f of g of x. And we know that 1 over x can be written as x to the negative first power, to the 2nd power. So now we have two options here. The first option is to multiply the two exponents and then to solve it. The second option is to use the chain rule to solve. let's use the chain rule because that's what this video is about. So when we use the chain rule, we have the outer function f of x to the 2 to the second power. So let's find the derivative of that. We have 2 that multiplies with 5, which is 10, times x, which is x to the negative first power, to the first power. And we don't have to write that down because we know that anything to the first power is the same value. Now we have to multiply it by the inner function. The inner function is x to the negative first power. So the negative 1 comes down and becomes the exponent times x to the negative 2 power. So this is equal to negative 10, because the negative 1 multiplies with 10, times x to the, here we have x to the negative first power and times x to the negative second power. So when we know that when we have exponents that are multiplying each other with the same basis, we add their exponents. So we have negative 1 plus negative 2 is negative 3. So that means that the derivative of f of g of x, which would be written as f of g prime of x, is equal to negative 10 times x to the negative third power. This can also be rewritten as negative 10 over x to the third power. Today we learned about applications of the chain rule.